Weekly Robot News. Robotics is an engineering discipline that deals with the conception, design, construction, and operation of robots. The goal of robotics is to develop intelligent devices that can help people in many ways. Robotics can come in a variety of shapes and sizes. A robot can be human-like or take the shape of a robotic application like robotic process automation (RPA), which mimics how humans interact with software to execute repetitive, rules-based tasks. So in today's video, we'll discuss weekly robot news and learn how improved AI is getting. Interested in learning more? So keep an eye on the footage. Hello everyone! Don't forget to subscribe to our channel, like this video, and click the notification bell button to stay up to speed on world politics, finance, the international market, space, and anything else in the world of technology. Number 4. Artificial intelligence learns coral reef song. According to new research, artificial intelligence (AI) can track the health of coral reefs by learning the song of the reef. Even professionals must do rigorous analyses to determine reef health based on sound recordings because coral reefs have a complex soundscape. University of Exeter scientists used several recordings of healthy and deteriorated reefs to train a computer algorithm, allowing the machine to learn the difference. After that, the computer analyzed a slew of additional recordings and correctly recognized reef health 92% of the time. This was used to keep track of the progress of reef restoration projects by the team. Coral reefs are under threat from a variety of factors, including climate change, making it critical to track their health and the performance of conservation programs. According to main author Ben Williams, one important challenge is that visual and audio reef surveys are typically labor-intensive. The fact that many reef organisms hide or are active at night limits the visual surveys, and the richness of reef noises make it difficult to determine reef health using individual recordings. The way we approached that problem was to utilize machine learning to see if a computer could learn the reef's song. Our findings show that a computer can detect patterns that the human ear cannot. It can provide us with more timely and precise information about the state of the reef. Coral reef fish and other species produce a wide variety of noises. The meaning of many of these cries is unknown, but the new AI system can tell the difference between healthy and ill reefs' overall sounds. The recordings utilized in the study were made at the Mars Coral Reef Restoration Project in Indonesia, which is working to restore severely damaged reefs. Dr. Tim Lamont of Lancaster University, a co-author, believes the AI method will greatly improve coral reef monitoring. This is a very remarkable development. Sound recorders and artificial intelligence might be used all around the world to track the health of coral reefs and see if efforts to conserve and restore them are successful, Dr. Lamont explained. In many circumstances, it's quicker and less expensive to place an underwater hydrophone on a reef and leave it there to send experienced divers to the coral regularly to survey it, especially in isolated areas. The Natural and Environment Research Council and the Swiss National Science Foundation financed the research. Number 3. The tiniest remote-controlled walking robot ever is a tiny robotic crab. Engineers at Northwestern University have created the world's tiniest remote-controlled walking robot, which takes the form of a tiny, charming, peaky-toe crab. The tiny crabs, which are only half a millimeter across, can bend, twist, crawl, walk, turn, and even jump. In addition, the researchers created millimeter-sized robots that resemble inchworms, crickets, and beetles. Even though the research is still in its early stages, the researchers hope their technology will help them get closer to developing micro-sized robots that can do practical jobs in constrained locations. The findings will be published in the journal Science Robotics on Wednesday, May 25th. Last September, the same group unveiled the world's smallest human-made flying structure, a winged microprocessor. Robotics is an interesting field of inquiry, and the construction of microscale robots is a pleasant topic for academic exploration, said lead researcher John A. Rogers. You may envisage micro-robots as agents in the industry to repair or manufacture small structures or machinery, or as surgical assistants in minimally invasive treatments, to unblock clogged arteries, stop internal bleeding, or remove cancerous tumors. Our technology allows for a variety of controlled motion modalities and can walk at a speed of half its body length per second, said Yonggang Huang, the theoretical work's leader. Achieving this at such small sizes for terrestrial robots is extremely difficult. The crab, which is about the size of a flea, is not propelled by complicated machinery, hydraulics, or electricity. Instead, its strength comes from the body's elasticity and resilience. The researchers employed a shape memory alloy material to build the robot, which, when heated, returns to its remembered shape. The researchers utilized a scanning laser beam to quickly heat the robot at various specific spots across its body in this case. When cooled, a thin layer of glass returns the deformed component of the structure to its original shape. Locomotion is created as the robot transitions from one phase to the next, from distorted to recalled shape and back. The laser not only activates the robot remotely, but the laser scanning direction also determines the robot's walking direction. For example, scanning from the left to right leads the robot to move from right to left. The pace of cooling is quite fast because these structures are so little. Rogers explained, reducing the size of these robots makes them run faster. Number 2, roboticists go off the beaten path to collect data that could be used to train self-driving ATVs. Researchers from Carnegie Mellon University took an all-terrain vehicle for a wild journey through tall grass, loose gravel, and mud to learn how the vehicle interacted with a difficult off-road environment. They accelerated the heavily instrumented ATV to speeds of up to 30 miles per hour. They slid it around corners, up and down hills, and even got it stuck in the mud, all while collecting data from 7 different sensors, including video, wheel speed, and suspension shock travel. Tartan Drive, the resulting dataset, contains approximately 200,000 of these real-world encounters. The data, according to the researchers, is the largest real-world, multimodal, off-road driving dataset in terms of both the number of interactions and sensor types. The 5 hours of data may be used to teach a self-driving vehicle how to navigate off the beaten path. Off-road driving is more complex than autonomous street driving because you have to understand the dynamics of the terrain to drive safely and faster, said Wenshan Wang, a project scientist at the Robotics Institute, RI. Annotated maps, which contain labels such as mud, grass, flora, or water to help the robot understand the terrain, have frequently been used in previous work on off-road driving. However, such information isn't always available. Even when it is, it may not be beneficial. For example, a map area labeled dirt may or may not be drivable. Dynamics-aware robots can reason about the physical world. The Tartan Drive research team discovered that the multimodal sensor data they collected enabled them to design prediction models that were superior to those developed with simpler, non-dynamic data. According to Samuel Triest, a second-year master's student in robotics, driving hard pushed the ATV into a performance arena where an understanding of dynamics became critical. As you add more speed to these systems, the dynamics become more complicated, said Triest, who was the primary author of the team's final article. When you drive faster, you hit more things. Number 1. Emerging technologies may benefit from the use of organic crystals as energy converters. Organic crystals, a new class of smart engineering materials, can serve as efficient and sustainable energy conversion materials for advanced technologies, such as robotics and electronics, according to new research published today in the journal Nature Communications by a team of researchers at the NYU Abu Dhabi NYUAD Smart Materials Lab. Organic crystals had traditionally been assumed to be brittle. However, the NYUAD researchers revealed that some organic crystals are mechanically quite tough. They created a material that sets a new world record for its capacity to change shape by expanding or contracting over half of its length without losing its precisely organized structure. Unlike traditional silicon or silica-based materials, which are inevitably stiff, heavy, and brittle, future electronics materials will be soft and organic. These modern technologies necessitate materials that are light, durable, and efficient in performance, as well as mechanical flexibility, and the capacity to function sustainably with little energy use. For the first time, the findings of this study show that certain organic, crystalline materials match the requirements of these technologies and can be employed in soft robotics, artificial muscles, organic optics, and organic electronics. Electronics created solely from organic materials. This recent discovery from NYUAD's Smart Materials Lab builds on a series of previous discoveries concerning the untapped potential of this new class of materials, which includes adaptive crystals, self-healing crystals, and organic crystalline materials with shape memory. Now Morph explained. Our research has demonstrated that organic crystals can not only suit the needs of new technologies, but can also outperform other, more common materials in terms of efficiency and sustainability. Having said that, as we near the finish of this video, we'd like to thank you all for sticking with us. If you enjoyed the video, please click the like button. Most importantly, if you want to be kept up to date on anything relating to space and the internet, you should subscribe to the channel and press the bell icon. Looking forward to seeing you in the next one. Until then, peace.